Hello, everyone. Very glad you could all meet us. You could all join us today. I'm Eli Leland, CTO and co-founder at Voltaic, and I'd like to welcome you to our webinar where we'll be talking with our guest, Electrified Veronika, about the topic of the state of battery AI, artificial intelligence, in 2025. So it's a topic that's been on everyone's minds, both batteries and AI, and the convergence of the two. So we're really excited to have an expert here to share what she's learned in studying this intensively over the last year or so. So first, some housekeeping notes. We welcome and encourage participation from our audience today. So please submit your questions just through the chat function on the side of your screen. Um, and I'll give a little background on our featured speaker today. So Dr. Veronika Wright is many things. She's a thought leader, author, content creator, and an electrification consultant. She has worked with many Fortune 500 companies and OEMs to help amplify and educate a growing audience on the future of mobility, the need to look beyond gas-powered vehicles and alternative energy solutions. On today's panel, Veronika will be joined by my co-founder and Voltaic CEO, Dr. Tal Sholklapper. Tal has been working on electrification technologies for over 20 years with extensive hands-on experience developing and commercializing fuel cells and grid storage batteries before joining me to start Voltaic in 2012. I realized I didn't have our intro slide shared, so I'll put that up there, and then we'll get started with the panel briefly. So shortly, so we will start with some material from our featured panelist, Dr. Veronika Wright, to sort of set the stage and set the context for the discussion, and then we'll dive deep on a couple different sort of application and battery lifecycle areas and we'll discuss the potential impacts for AI in those segments specifically. And so without further ado, I'd like to introduce our featured speaker, Dr. Veronika Wright. And Veronika, you're welcome to share your screen and take it away.
Awesome. Thank you so much for inviting me. And I'm really looking forward to this discussion. Let me just get settled. I think you can see my screen now, right?
Looks good.
Yep.
Okay. So yeah, today's discussion is about the state of battery AI in 2025. Probably we want to add the month because AI, this space is moving so fast that each day everything is different. But anyway, so let's set the stage a little bit. So I think when people think of AI, they think of ChatGPT, which is awesome. But there is so much more than that. And I was personally very, very curious to understand where artificial intelligence is actually applied in my own industry. So last year in 2024, I went on a quest and tried to find leading companies in our industry and talk to them about how they use AI, not only in their private life and in their business in general, but then especially how it is applied in the battery world on their products and offerings to their customers. So I went ahead and kind of created this podcast series and just want to clarify, I personally am not an AI expert. I did my PhD in technical physics, and our team back then started applying machine learning algorithms to identify the most promising variants of how molecules would arrange on surfaces. You know, there's so many variants, you can't really calculate all of them. And with machine learning, you can get there fast. Nobody back then called that AI, but according to today's definitions, it would be. So let's jump into a little bit of the classifications of AI. So on the left here, you can see a picture of Accenture laying out kind of the typical battery manufacturing line with electrode production, with cell assembly and cell finishing. So down below, it's the physical space with all the machinery. And then on top is what you have like the digital space. And, you know, there's a lot going on. You can see enabling technologies like artificial intelligence and machine learning. You can see building up digital twins, which are the virtual representations of those batteries. And then you see a variety of different use cases. The thing to point out here is that sometimes people tend to think that AI is now just a magic tool that we just apply and then the magic happens. But it's really not. It's really a higher hierarchy of needs that first need to be fulfilled before you can even start trying to apply AI. And the foundation of everything is collecting data. Be it with sensors, be it with instrumentations, logging, maybe bringing in external data. And we can use here the example of a battery manufacturing line. Then next, you kind of move around and store that data in the right ways, build up your infrastructure, structured and unstructured data, and find the right pipelines. Then once you're done with this, you kind of transform, maybe you do some cleaning, some anomaly detection to really prepare the data in the right way. You aggregate it using segmentation methods, metrics, and analytics. At some point, you can start applying some testing and experimentation and learn and optimize. And only if this is all done, then you can apply artificial intelligence. Now, I also kind of like to look at artificial intelligence and trying to understand kind of what is the difference between data, between algorithms, and artificial intelligence with this picture here. So, when I was kind of hosting the podcast and talking to people, everybody had kind of their own definition of what artificial intelligence is. I had Paul Razor say AI is the science of making machines smarter. It's about building things that give intelligence to machines and software, enabling them to think, reason, and create. Then I had a more technical definition of Dr. Jason Köhler from Chemex, who says AI maps correlations between inputs and outputs. It's about showing the computer many, many examples of what you want it to do, and then letting it learn from those examples. So there's lots of different definitions, but I think it's kind of nice to see. Starting out with algorithms, an algorithm is in a way just a set of rules or instructions to kind of solve a specific problem. And then a set of algorithms is actually artificial intelligence, and we can call it trying to simulate the human intelligence. Then a subset of that is machine learning. Machine learning is a data-driven type of artificial intelligence. There are so many more options. A subset of this is deep learning. And deep learning is really kind of the foundation of today's AI, also the foundation of ChatGPT. Now, last slide about more like the classifications and understanding how it all works together is giving a little bit of history, because I think it's kind of interesting too to see that. So an algorithm, in a sense, was first defined in 1936, really with the Turing machine. That's the modern definition of an algorithm. Then in 1956 was actually the first time that AI was defined as a formal academic discipline, more like the if-then type back then. In the 80s, we had machine learning and neural networks and all that kind of developed. And really the breakthrough for today's AI happened around 2000 with deep learning really beginning to transform everything. There is this very famous paper, Attention is All You Need, about large language models, transformer networks. And then, as we all know, in 2022, and since then, everybody is kind of using either ChatGPT or any of the other 1,000 tools, using AI, having access to unlimited knowledge, if you will, without needing to be a data scientist or a programmer. And I like to say that this is the death of a consultant like me, because, I have built up so much knowledge, databases, and so many things over the past years. And a lot of that is now really accessible through ChatGPT. And yes, it's not perfect. And, the AI that we see today is really the worst AI that we'll ever have. But it's such a good starting point. And you really have to make use of this. Now, this is now the most nerdy slide that I prepared. It's me trying to figure out what types of artificial intelligence there are Like I said before, there is more than machine learning and deep learning. It's kind of funny when I try to classify that. I talked to a friend of mine, and he's really an AI expert, and he really said the only branch of science that I know with more BS published about than AI is the search of UFOs. So I think it's really important to really talk about what we actually how we actually define artificial intelligence. And you can see there's so many more things than machine learning. There is non-data driven types of AI that are rule-based. There is swarm intelligence, expert systems, generative design. And then even within the branch of machine learning, which is currently the most dominant one, we have different types of learning. And yeah, at some point, just to give you a reference again, within the deep learning, transformer networks, and large language models, at some point you'll find ChatGPT, what we all know, generative pre-trained transformer. Next up is now really bringing this back to the battery world. Why is this now? So I think, and a lot of other people think, there is a huge potential for AI to be applied in the battery world. Why is that? Understanding batteries is not trivial. So how a battery actually works, really considering all the processes that happen at the same time, especially when they age, is something extremely complex. And I would say nobody has figured it out yet. Yes, we have approaches. We do electrochemical modeling. We do lots of testing. We try to combine all that with aging information and, again, testing and stuff like this. But there is no one model or one way that we as humans currently can understand lithium-ion batteries. So there is really so much potential to do it in a different way, a more data-driven way, probably using something like artificial intelligence. And why is this so important, or what's important to enable that, is kind of harmonization and standardization of data. Like I told you before, in order to apply AI, you have to have a foundation. And especially in the battery world, there is really a lack of standardization, especially once we talk about life cycle data. And two examples here are, battery state of health determination. So everybody's listening in who is in the battery world, you will know there is no standard definition of a state of health. We don't really understand to the very, very detail how batteries age. And we really need to access historical battery data to determine and certify SOH. For example, also, think of a practical application like the value of a used electric car. Nobody really has figured that out, if we're honest. The other big area where standardization, or the lack of standardization, is really a problem is recalls of where the battery was the problem that actually goes back to some type of manufacturing problem. So for that, really, lack of standardization of the cell lifecycle data makes it so hard to monitor battery performance, track and maintain batteries, and at some point also ensure safe reuse and recycling. So yeah, we can help all that with, figuring out what the right data is that we need, and then at some point apply artificial intelligence to this. And coming back to kind of the introduction slide where I told you I was on the quest of figuring out how AI is applied today in the battery world. So I try to find one company, one representative of each part of the battery value chain and try to understand what they are doing with artificial intelligence in that area. And it really started out by using AI for battery chemistry and design, going into battery testing and development with Monolith. Then next up, AI in battery manufacturing with Hexagon. Then a couple examples, once you have your cells and you integrate them into packs and you have to, for example, add in the thermal management, there's a company called Diabatics that uses AI here. Also in the BMS side of things, Electra and Texas Instruments, virtual sensors with ComPredict. And then I even went all into the EV charging and at some point the recycling again. So if you're interested in kind of really understanding all the details, I recommend you watching that podcast series. And I think now what we want to do is kind of talk through a couple examples here that are relevant to the discussion today. And it will start out with battery chemistry and design. And I think this would now be the point to kind of start a discussion, right?
Yes, indeed. Yes, thanks. That was a terrific introduction and overview. Obviously, it's a very broad topic, and the battery industry itself uh, is very large and expansive, and touches on so many things. So there's a lot of different places where things can intersect. So yes, we thought uh, for the conversation going forward, we would kind of focus on a couple different sort of application areas and life cycle areas. And so yes, the three we're going to cover, we're starting with AI and battery chemistry and design, and then we're going to do AI and battery manufacturing, and then the potential for AI in automotive generally. So we'll start with AI and chemistry and design. So yeah, Veronica, you're welcome to put up that slide, and if there's anything you want to kind of talk through as an overview of how AI is being, I think perhaps the way we could introduce it and what we'd like to cover in each topic is effectively what are the key use cases that you're seeing, the places where AI is actually being used and actually having real world impact and adding value. Secondarily, what in each area, what is really kind of at this point just hype in terms of either what people are saying AI might be used for, or perhaps more charitably, what people are hoping and anticipating AI might be used for in that application area or life cycle stage, but it's really kind of not ready for prime time yet. And then again, and you've touched on some of these more generally, but in each area, what will be the key enablers to adoption or the key barriers to growth and value of AI in each of those segments. So yes, we can start with in battery chemistry and design. Where are you seeing AI adding value now or having real near-term potential?
Yes. So, yeah, I mean that's actually a perfect example because it also brings me back to my PhD that I did in technical physics, which I told you already was a little bit in a physical chemistry area, trying to discover new materials, trying to discover how molecules would actually arrange themselves on metals. Why am I saying that? There are so many different variations that with approaches that are not using any data-driven methods or algorithms, you will not be able to finish ever. So back then already, like discovery of new materials is really one of the key areas that AI can be applied to. And this is no different in the battery world. And this first example is of a startup called Chemix. They're based in San Francisco. They are really completely, in my eyes, revolutionizing the way that we design and come up with new chemistries, design batteries and come up with new chemistries. So they're really kind of integrating AI into the whole battery development process. So they're using AI to simulate and predict the behavior of new materials and of essentially reducing the trial and error process of battery chemistry development. You can see it a little bit here. They also call it kind of self-driving lab. And I think what I want to point out here is that when we are, as an industry, designing new chemistries for batteries, designing new batteries in general, what we used to do is design experiments that we as humans think are the right ones to create the output that we hope for, right? But the way that Jason and Chemix are doing that and the way that he described it is really flipping the coin. It's like actually let AI come up with the right design of experiment. What are actually the tests that I have to do? And then let AI and all the data that it kind of generates find correlations in order to make a battery and the chemistry for a certain application. So maybe that's the starting point of what they're doing.
Excellent. That's fascinating. So I'm curious. Do you have any sense, and Tal, you're welcome to jump in here too. So AI is being applied effectively to do something very similar to what the traditional way of doing this development in terms of design of experiments, kind of exploring the parameter space, iterating towards a set of performance goals. Um, in practice, I wonder if we've seen any kind of evidence or quantifiable impact of like sort of what's the difference either qualitatively or quantitatively between a design of experiments that an AI generates versus one generated through sort of traditional statistical methods, and or if we see, you know, I don't know how easy it is to sort of compare one to the other if anybody's doing like an A/B test effectively of traditional DOE versus AI. But I wonder, either of you, what you've seen is um, in practice what the difference is in doing this sort of iterative development using AI versus traditional methods.
Yeah, so what Jason had shared with me, there's two things that are different to the
Yeah.
traditional approach. Like
Mm-hmm.
one thing is that the time that you spend for development and getting your first results and actually then manufacturing is drastically reduced. And the second is really that with this whole system, you can see here Jade by Mix, that's the
Mm-hmm.
actual battery, a pouch cell that they created,
Mm-hmm.
is that with AI and all that development on autopilot in place, they could achieve higher density and lifetime compared to state-of-the-art lithium-ion batteries. Yes, still in a very early stage, but having worked in this space, especially also I was once the one who set up a DOE, using a little bit of statistical methods. I can absolutely see the potential and trust the results here.
Yeah.
Awesome.
So I think my take is a lot of these applications, the reality right now is it's a lot of statistical tools, but the AI is actually just chaining them together in terms of a way that it creates this closed feedback loop. The algorithms themselves in large scale statistics and finding correlations we've been doing for years, and it's really pairing that together to create this closed feedback loop to accelerate things. I think just going back to the start, it's interesting where you find ML versus AI in the chain of how you stack, look at the view of the world here. But yeah, I think the key is, a lot of these tasks that require those manual iterations, whether it's getting the data to feed into the DOE tool or the AI algorithm, or then getting it to spit out that next iteration, is a lot of those steps were really done manually, but the ability now with software to automate those things is really what is creating these ability to do very fast feedback loops within the environment. So there's still a little bit of marketing, I'd say, in terms of just what is just linking algorithms that are very traditional versus what is an actual deep learning model. But with software and automation and building up that hierarchy, you can actually do a whole bunch of great things today that take a whole lot longer if you do it the traditional way.
That's a really interesting perspective, thinking about AI really kind of more as the glue than the kind of mastermind brain that's coming up with the result. But as we all know, there can be a tremendous amount of value in just sort of automating those interactions. And I know in fields outside of batteries, people are really excited about AI to integrate sort of legacy, computer systems that small businesses use to run, to integrate them to the internet just by just by the AI being able to recognize what this field is semantically and mapping it into some other system. So as opposed to drawing any real brilliant insight, it's just sort of automating all of that manual work. So that's a really interesting perspective here.
No, and I think it's worth teasing out a little bit further.
Yeah.
I think one of the key things you look at Jason and Chemix have done beyond the chaining is they have all of their data in a centralized platform. If you look at a lot of the research efforts, because it was so hard to automate, so hard to get all the data in the right places, individual researchers basically look at the data that's in front of them at that time. And by having your broader body of data in a centralized location in the right language, all cleaned up, that's where you can start leveraging those unknown interactions. It's not just the 3 parameters you change in your design study. You can now run that algorithm, whether it's statistical or AI, across now the body of all of the different parameters that have evolved over your entire organization, testing batteries and iterating. So it's, rather than piecemeal on each of those little studies, you're now able to look across all of this data and start running these things. So it's the automation and ability to run this across a lot more data all at once that is really key.
And maybe to add on to this, right now, I mean, there's a couple companies like Chemex who are really starting with this whole thing from scratch, right? So they are kind of designing everything that they do and all the tools that they use and how they test and everything really from scratch. And they can do it in a way that they can then easily apply AI and don't have to go through all the hurdles that some of the companies that already have their existing processes and routines and tools and everything, they still have to go through the hierarchy of needs in a way and set everything up again and harmonize data. And so this is something that, of course, I'm assuming you see a lot working with your customers, but I also have this experience that how much effort it is to just get the right data, first of all, accumulated, but then harmonized and prepared before I can even start thinking of applying AI. Just like I mentioned before, I think this is also something to consider.
100%. Yeah, I think that's ultimately, when you talk to a lot of AI experts, it's a lot of it is, at least in the battery world today, it is just regressions that they're running and looking for correlations across lots of data. The key is just getting the data in the right place in order to run those analyses.
Indeed, yes, that's something we say a lot. Is that basically, in order to apply any of these sort of advanced techniques, you really have to get your data house in order and get those pipelines set up and automated and scalable in order to start making any headway on this. So briefly, I wonder if either of you have perspectives on either what is just hype or what are sort of in chemistry and design, what are kind of the outsized expectations that people might have for it. I think the one that comes to mind is just sort of, so this iterative approach makes sense, but it's sort of out there in the ether that AI might be able to just predict the perfect, combination of anode cathode electrolyte materials that'll make the magic battery. What are your thoughts on that, or anything else you see of expectations relative to reality?
I mean, maybe I can just start with, like, coming back to the AI that we see today and all the applications, like the worst that it will ever be. Sorry, what was the question? I kind of lost it for a second.
Yeah, just sort of along the lines of if you see any areas within this sector that expectations are out of line with reality or kind of near-term likely value.
Yes, expectations are a little bit out of line in a way that right now, even if you talk to AI companies, there is lots of human involvement. There is lots of humans having to kind of give the limits to what AI can do. And I think what we see very quickly over time is that there will be less and less of really human interaction until we can actually reach an AI that some people might talk about already now. But I think this is kind of the step-by-step approach. Like, we have to provide a framework right now and so much data and so many data points and kind of limitations and a framework. And over time, I think AI and those systems created, they will learn, which needs less and less human interaction. I also had the same discussion with diabetics who use AI for thermal management, like the plates design. They say the same thing. Right now there is lots of human input, and then over time this will become less and less.
Fascinating.
Yeah, I think from my perspective, it's a lot of people, are very excited about AI. There's a lot of exciting things that you could do with it, but they sort of start at the top, like, let's spin up a team to do AI, and they don't realize how much of that pyramid that you laid out, Veronika, that they have to put together first. And so you have, companies that'll hire an ML engineer, bring one in from a different part of their organization, and they come in and they end up pulling their hair out because they realize how messy and how the data is not organized, there's no common naming, there's no all of that stuff. And it's just that in the reality is you can't just plug in and say, we're going to start an AI initiative. It's actually the building out the data foundation in order to start these. And that's the starting point to start putting this all together. And then the other thing is there's actually a nice, saw it this morning on LinkedIn, one of our friends, Richard Alfred, who from Monolith, who was on the podcast series, just talked about, in his time working on AI initiatives, it's the gap of like imagination that people have around what AI can do, what the data actually shows. And the point he was making is that you actually need the relevant underlying data to look for the interactions and things that you're looking for. So if your body of data doesn't have, new materials that are outside of your lab, it's not going to come up with a random new one outside of that. You need to actually look at what are the proper boundary conditions. If you've never tested an LFP battery in your lab, it's not going to magically, if you're all testing NCM, it's not going to give you, a random, iron battery. You actually need to define the problem set and what the AI can learn across in order to make those interpolations for you. There's still some work to be done.
I'm really glad you brought that up. That actually directly addresses a question we got in the audience chat, which is, what are some new approaches being taken in the industry to increase confidence in learning model predictions in regions outside the range spanned by the training data set? So I think the conclusion we would draw from this discussion is that you can have some amount of confidence in the range of data spanned by your training set, and outside of that, you should be cautious and skeptical, I think would sort of be the take. So that's all right. That's a terrific overview of AI and battery chemistry and design. So Veronika, I'd love for you to introduce the next topic of AI for battery manufacturing.
Okay, so for that topic, I actually talked to a company called Hexagon. They're international and they're doing lots of different things. And the division that I talked to was Hexagon Manufacturing Intelligence. And there is lots of different areas that you can apply AI in battery manufacturing, but the ones that were mentioned here, and now we're really down in the cell manufacturing, is, AI-driven systems to kind of inspect cells and kind of inspect separator films, anode overhangs, and coated electrodes using like non-destructive methods like CT scanning. So that's now a completely different application and also different technology used here. Big goal is, of course, reducing scrap and understand where problems come from in the cells. It's computer vision and deep learning algorithms to kind of detect anomalies early in the production. So that was one of the areas. There is so many areas, especially now when you go also into the module and pack manufacturing, but this is something focused on the cell manufacturing.
Excellent. And do you have a sense of like where in practice in the industry, Veronika or Tal, you're welcome to jump in too. So lots of potential. Where are these techniques, technologies, and systems actually being used today?
Yes.
And for the ones that are more prospective, nobody's going to hold you to this, but what do you think the timelines are for actually seeing them deployed more broadly?
So you will not be surprised. And of course, I asked that almost every participant. How is it received? How is an AI-driven methodology, product, whatsoever, perceived and received in our industry? And all of them were saying, yeah, we're applying it in China. And essentially, Europe is a little more careful, and the US is kind of in the middle. So especially also here, I remember Hexagon mentioning that they have customers doing that in China. It's mainly driven by, of course, efficiency goals. So this is definitely something that is applied today, but with a little bit hesitance in Europe and the US.
Interesting.
Yeah, I think from my side, what we've seen in practice around AI at factories is absolutely it's much narrower. Everyone talks about AI across the whole production line. the reality of what we've seen is it is absolutely in practice a much narrower image analysis because humans cannot be in that loop. And so you need tools to be able to identify those defects and issues. In practice, a lot of it is feature extraction from images and then actual just max min thresholds, not real AI notifying you of something different. It's just, is there, scratch or, gray dark area in this image, and is it above a certain percentage or is it above a certain length? And it's literally just a max min threshold. And so that's the reality of where it is today. I think it is starting to come together as far as the broader factory is now these digital threads really get pulled up. Theoretically, we've had these for a while, in centralized data backbones with, MESs or data lakes or historians, whatever the names, wherever those repositories are. The reality is a lot of the data that is relevant for this kind of a deeper analysis is actually still living on the PLCs and doesn't make it up into those data collection layers. And so a lot of what we're doing is, first pass helping companies, leverage the data they have to start pointing them towards, you had a problem downstream here in formation or an aging, high voltage drop, where did that come from? And at first pass, just given the data that is available, you could tell them, hey, it's coming from the winder, or it's coming from this mix, or it's coming from this, lot of material that's coming in. And then you could sequentially really work with customers on, hey, if we want to start doing more advanced analysis, let's actually start collecting data from this frequency from the PLC, bring that into that centralized data lake. And so that broader application, is starting to now come together. But in practice today, a lot of it is very narrowly applied across the production line.
Yeah, and if you think about manufacturing is really such a big space, and I was surprised to not find so many companies who actually claim it or do it. So like you say, there's a lot of potential, and I think that's something we also talk about in the next slide that shows it in the manufacturing space that it's not used yet.
Awesome. So again, I'll turning to the sort of what's hype or what's outsized expectations relative to the present reality. I know I've heard in sort of industry chat within the battery sector that there are companies that are developing an AI to run an entire battery production line. How close or far do you think we are from that? In the I suppose in a similar way that you showed with Chemix, and Jason Kohler and his team have sort of put together this end-to-end workflow that's powered by AI, especially in terms of joining up the different parts of the workflow.
Yes.
Are we seeing anything like that in practice in battery production? And if not, how close or far are we from something like that?
I think we're far away. Like we discussed. So there is little niche areas like this one where AI is applied, but I can absolutely not believe that there is something up and running, an AI that produces batteries in a way. So why? Manufacturing is extremely complex. We know that. We have lots of different process steps. We have lots of different equipment, physical equipment that needs to work together, that all has kind of different technology. This is different than when we talk about battery chemistry and design, where most of this, it's simulated, it's in the virtual world, if you will. So there is not really a connection to actual manufacturing processes. So I personally believe that this is far away from really happening, because there are so many other things we need to first figure out before we can apply AI. Maybe it's not the right approach though, but I think that's the current status.
Yeah, I agree. It's I still think the narrow applications have a lot of value because there are significant pinch points around the production environments, and there's some of our partners that do simulation work trying to create that closed feedback loop around the coding process. And I think there's opportunities to really hone it in on parts of the production line where there are pinch points, and excited about that. In practice, it's still not there yet. The reality is, a factory and the design teams that know the modeling work are mostly in R&D. The people who are actually running the line are more of the operators and process engineers, you have the quality engineers on the back end. And so connecting all those dots is very hard in practice to pull this together. But I think on areas where there's specific pain points, I think it's really promising. And I think there will be effort, and probably in the near future, we'll start seeing some closed loop in manufacturing around something like a coding process before we see it across the entire production line.
Yes, indeed. And just to layer on a little bit more detail, so something that we hear all the time in engaging with cell manufacturing customers is they would like to know before cells get all the way to the end of line if they're going to be defects or if there's problems in the upstream material. So part of that closed loop that Tal's talking about is you're instrumenting something like the coding process. You're correlating later to the downstream quality through end of line QA or other methods, and then in the future when you see you can correlate what sort of upstream conditions map to bad cells coming off the end of the line, so that when you in the future see those conditions upstream, you can intervene before those cells get all the way through final assembly and QA. I think that's something that is certainly under development. I don't know if it's in broader adoption yet, but I think that's one of those sort of feedback loops that Tal's talking about that we might see sooner rather than later. Wonderful. So with that, I'd love to transition to AI potential in automotive and electrified mobility.
Yeah, so I mean, this is kind of bringing it all together, if you will, or trying to get the big picture. So that's a study from McKinsey from 2018. I have not found anything really that's up to date, where people or companies were really looking at what's the potential of artificial intelligence in automotive in general. But I think this is still kind of relevant. So what you can definitely see, also kind of referring back to the last slide, is that the highest potential that McKinsey sees for AI in automotive is in manufacturing. So there's a huge value potential in manufacturing, data-based insight generation, be it, like you just mentioned, predictive maintenance, so we can reduce the scrap and monitor parameters. Is it inline digital quality management or AI-based process automation? So I think there's just really, really a lot of potential for AI, specifically here in the manufacturing.
Interesting. And I know you talked, it is part of your webinar series, which Tal and I both listened to. You've talked to a couple of companies that are working in other parts of automotive, I guess, besides manufacturing, in terms of product development, BMS, things like that. What sort of trends are you seeing in terms of applications of AI in those areas?
Yes, I mean, I think we'll see more and more in all different areas. So when you look at the whole battery life cycle, I found a lot in the design and development process, not so much in the manufacturing, a little bit in the EV charging, and then it was pretty much it. So on the reuse recycling side, there is not so much happening. So it's kind of reflecting what we can see here. I think supply chain management will be also an area. It's also highlighted here. That's very interesting to apply AI. But yeah, so that's pretty much the status.
Tal, any thoughts on where we're seeing AI and advanced data methods in automotive specifically?
Yeah, it's where you have structured data is really key. Just looking at some of the audience questions on the side here. You need data sets in order to train across. And so I think you are seeing like image inspection and analysis of, even things like body panels and alignment and things like that people are putting into practice with more advanced techniques. The design and R&D space is probably the next up that we're seeing a lot of these efforts actually implemented as well.
Excellent. So yeah, I think there's been a question brewing in my head and thinking about preparing for this webinar that kind of ties into this, which is, I think, well, speaking for myself, and I think probably a lot of other people in the community, when ChatGPT first became available, about a year and a half ago or so, it's sort of everyone started imagining, when are we going to get to Bat GPT, right? This sort of comprehensive magic global algorithm that can predict every battery's performance, degradation, lifetime, quality, etc. And I feel like that ties into a lot of when we talk about what might be hype or outsized expectations in the automotive sector. I feel like um, when we engage with certain parts of this community, there are notions that we can't be that far away from that BAT GPT algorithm that is going to tell us exactly what the charging protocol needs to be, exactly what the BMS algorithm needs to be to optimize the battery for every use case. So I just wonder if either of you have any comments in general on how near or far we are to that global comprehensive algorithm and what it might take to get there.
I think we're further away than people think, because the biggest issue is for that to happen, we need to share data across the life cycle and harmonize it. Coming back to the things we talked before, the battery passport initiative. I mean, how many years? It's probably a decade now that we're talking about it. Yes, there are certain things happening, but we're not moving fast enough. So as long as we don't have something like a battery passport enabled throughout the whole life cycle, I also don't see this to happen.
I agree. I think in order to really do this, you're trying to predict lifetime operations. There are just so many of these pieces, and they are segmented across different parts of the ecosystem right now. And so being able to put that together is really key. I think the applications where the natural language interfacing is really interesting, of being able to ask questions, and areas where you have text-based analysis of what went wrong, or what the result was like. So where you have not just data, but also reports on the data, like a failure analysis or study, and like an analysis of that, create some interesting opportunities for natural language interaction with the data, which I think are going to be really exciting going forward as well. But we're quite far away right now from, tell me what battery to use in my application and how to charge it. And it'll take quite a while. And part of it, the challenge is it's how long it takes to see if a battery is good or bad. And especially with some of these applications where, it's 10 to plus year lifetime, it's going to take us, going back to the quote from Richard, we actually have to see these things through in order to really understand the long-term implications of those design choices we make up front and how those tie in.
Excellent. So yes, we're drawing near the end of our session. I think we'll take a couple more questions from the audience chat, but I just wanted to draw attention to the polls function in that chat bar. We'll be putting up a poll for the audience in just a moment, so take a look at that. Be on the lookout for that. And yeah, so just a couple questions, sort of going through different parts of our conversation. So we have a question from Martin that touches on the manufacturing topic. From your understanding, does the average battery production plant yet generate enough data to enable AI, or is step one to add more sensors to the equipment?
So from my view, you can provide value from the data that is collecting today. There are a lot of sensors that are already being, they're already in place to run the PLCs and controllers that are running the production line. And you may need to surface that data, but that data in itself actually has value and will allow you to run feedback loops, optimizations, correlations, all that fun stuff. And so the data that's there is valuable. So first step, make sure to get that in. It adds another whole layer of complication for an existing production line to layer in additional data sources that are not synced with those controllers. And so leverage what you have today, and then look at opportunities to add more metrology and more sensors to the production line.
I think one thing to consider here also is, I agree. I think that we have enough data, probably. Still think there is some innovation possible, but it's also kind of what you want to achieve with AI. I'm just thinking now, I've worked on a project where we were coming up with a virtual representation of a battery for a certain chemistry in a production line. And now once something changes in the chemistry, how can you transfer that to the new one? And so yeah, I think we have to be very careful when we discuss this. Like, what do we actually mean by optimization with AI?
Yeah, and I think fundamentally, before you go, batteries are pretty low margin business at the end of the day, and so you really have to ask yourself, what are you looking for? What are you trying to get? Where are you seeing the failure points? Look at that Pareto of failure points. Does the introducing these additional metrology or sensors, does that pay for, is the return justified on the added complication of adding these things? And you'll often find if you choose your areas well that you're targeting, the return can be actually very large. But it's really figuring out where you're dropping off, where you're losing materials, where you're losing devices, where that path is coming from. That's really key to that exercise before you layer in more sensors.
Excellent. I think it's, the message is loud and clear that there's a lot of value to be gained here, but that we need to have sort of measured expectations and pick, at present, given the state of the technology, pick specific application areas where we know we can get value before leaping ahead to this comprehensive, magic AI brain that's going to solve all of our problems, which, I think it's probably common sense, but it's good to hear it and talk about it in this discussion. So we're going to close with one final question, which ties back to a couple of the enablers. In fact, I'm going to sort of synthesize from a couple different audience questions. So there's one from Carlos. How much emphasis need to be placed on the preparation of the data collected? A lot of us have traditionally prepared data sets for human ingestion. How much of this needs to be reframed for proper machine consumption for effective learning? And then related, what would be the minimum state of data management for an organization to start using ML and AI? For reference, my organization primarily has spreadsheets across a network drive. Would an unstructured database be sufficient to be useful, or would it need to be structured or semi-structured? And that was from Garrett. So 2 questions on that theme that we'll close with.
I think these are both Tal.
So the reality is that data, there's some, can't remember who came up with the initial quote, but 90%, I think it was actually a Google paper they put out back in the day. It was like 80 to 90% of any ML, which they used to call it at the time, of the work is actually cleaning the data and extracting key features from it. It is all that is the key piece of the puzzle here. And so getting that data into machine consumable tools is really key, and getting that organized and cleaned into a common language, we call that harmonization, getting it traceable and linking it. It's great if you have 2 spreadsheets, but if you can't figure out which electrode roll went into which battery, it's useless. The machine doesn't know how to make that connection unless you provide the link. And so I think the data is the key, and I think the underlying piece here is figuring out where you want to spend your effort to do that. A lot of what we have focused on at Voltaic is sort of meeting customers where they're at with the information and data. And so a lot of it is some of it is already in a machine and data files. Some of it's in Excel spreadsheets or Google Docs. Some of it is in LIMS or MES. And sort of creating pathways to automate the ingestion of that data into one centralized location, and creating the needed traceability, creating the harmonization into a common language, extracting those features, has really been our focus on that underlying infrastructure. Unfortunately, we've seen a lot of these, AI teams who are tasked with doing that, and because it's such a Herculean task, they'll do a study on 10 batteries or 50 batteries and sort of over extrapolate the results to try to showcase the value, and then when they try to apply that more broadly in the organization, you end up having failed efforts. So it's really about figuring out, great, show that proof of concept, but really the emphasis needs to be on that background of getting the data right up front so that you can do this across the entire body of data.
And I think like the questions about how much data do I need do I have enough data? We can't answer that. There's nobody that can really give you a number or anything. Like, it's so specific. And I think, yeah, you just really have to talk to Tal and the team to understand that problem specifically. And the other thing I want to add is, and I just looked up the podcast with Richard again. He has some really nice quotes.
Yes.
There was one question, how can I prepare the data so AI can read it in a way?
Mhm.
And towards the end of our podcast, Richard actually said here, with my approach of solving the world's energy problem is that there's a chance that we will solve it, but we won't understand how. I think this quote is interesting because today, the way we set up AI systems, it's still in a way that we can understand it. We humans can understand it. The data is prepared in a way that we can still read it. But I think it will transition to a point where it will be in ways that we'll not always understand what's happening. That's also, of course, a little bit scary. But I think this is kind of where it's headed to.
Indeed, yeah. I know there's a sort of big, broader topic in AI around explainability of why a model is giving a certain result, and hallucinations by the various LLMs and things like that. So a lot of really awesome questions coming up here toward the end in the chat, but I think we're just about out of time. So I think we'll close this session now. But incredibly grateful to Dr. Veronika Wright, Electrified Veronika, for joining us today and sharing her perspectives on AI in the battery space. And we'd love for those in the audience who have questions that didn't get addressed, just please follow up, get in touch with us at Voltaic, or get in touch with Veronika. We're present across all the channels. I definitely encourage everyone who hasn't heard it yet to listen to Veronika's podcast series, which I know is available on Spotify. That's where I heard it. And then the recording of this webinar will go up on our YouTube channel, the Voltaic YouTube channel, and everyone who registered will get a link to the recording afterward. So yeah, we'd love to continue this conversation. It's such a rich topic. As you said, Veronika, it's moving so quickly. The AI we have today is the worst that it's ever going to be. So, I'm sure that this is a topic we'll be revisiting some months down the road regularly as part of our content series. So again, thank you, Veronika. Thanks, Tal, for joining us as well. And thanks to everyone from the audience for all the great questions. Really appreciate it.
Thank you.
Thank you.